An airplane releases a ball as it flies parallel to the ground at the height of 255 meters. If the ball lands on the ground at a horizontal displacement of exactly 255 meters from the release point, calculate the airspeed of the plane. So to analyze the situation, let's visualize and make a picture. So suppose this is the ground and we have airplane. I'm gonna just draw like a rectangle. This is our airplane, which is 255 meters above the ground. 255, and it releases a ball that actually is going to land exactly 255 meters at the range. So let's call from here to here to be 255 meters, while the airplane is moving horizontal to the ground. So we want to find out what is the speed of the airplane. To solve this problem, let's understand one thing. Well, since the ball was before dropping was in the airplane, so the ball also was moving with the same speed as the plane was. So when the ball has been released, the initial velocity will equal to the plane's velocity. The initial velocity is solely in the horizontal direction, so I can draw the initial velocity of the ball to be the same as the velocity of the airplane and at the horizontal direction. Also, for simplicity, we will set the origin of the plane's initial position to be positive x and up to be positive y. I meant going to the left to be positive x. So let me, because it's much more convenient. So I'm choosing my positive x going to the left and positive y going upwards. So my numbers will be a little bit better. Now let's write down what we have. Obviously, this is a projectile motion. We have to resolve everything into components, the motion into x and y component, so horizontal and vertical. So let's start with the horizontal component and see what we have. We'll make the table for what's known. Let's say we have a delta x here, v naught x, vx, ax, and t. Let's do the same for the y, delta y, v naught y, vy, ay, and t. So the delta x is, if we consider x initial to be 0, and then which is right here, right? And x, the final position of the ball, would be 250 meters. So delta x equals x final minus x initial, which equals 255 meters. Remember, it's positive because going to the left is my positive x. V naught x is actually what we're looking for. This would be the plane, also plane's velocity. We want this, and it's a question mark. We don't know the Vx, and we know that the acceleration on the x-axis is 0, and we don't know the time. Well, that's not a good luck for us, because we have 2 out of 5 quantities only, which means we cannot find any of the other 3s. So let's see what we have on the y component. So let's go back and then identify our y initial is 255 meters. But then y final is 0 meters. So delta y equals y final minus y initial, which equals 0 minus 255 meters. That is negative 255 meters. And then for v naught y, we know that this is 0 meters per second. That's a good sign. We don't know the Vy, and we know Ay equals negative 9.8 meters per second squared. And then we don't know the time. Let's try to understand, why do we need V naught x? How can we find the V naught x? Because remember, we want to start from the point where what is asked from us. So to find the V naught x, we're going to use the equation delta x equals V naught x times t. From here, I can find V naught x equals delta x over t. So therefore, I need to find the time from the y component to plug in into the expression that I have. So I want this now. So when I find the time, I can plug it in here. Well, let's go ahead and see what expression is best for us. As you can see, we from our kinematics equations, the one that involves delta y and time and v naught y and acceleration, that's the third equation, where we have delta y equals v naught yt plus 1/2 ay t squared. So this term is going to be 0 because v naught is 0. Delta y is negative 250. Let's solve for t first. So from here, I can find 2 delta y over ay equals t squared. And then I can have from here t equals square root of 2 delta y over ay. So plug in the numbers, we will get 2 times negative 255 meters divided by negative 9.8 meters per second square. Let's plug this into the calculator. I get 7.2 seconds. Now I can take this 7.2 seconds and plug it in into my expression for v naught x. So let's go ahead and make this equal to delta x was 255 meters and the time was 7.2 seconds. That equals 35.4 meters per second. So this would be my answer. So as we said earlier, before before the ball has been dropped out of the plane, the ball and the plane were moving at the same speed in the same direction. Therefore, their initial velocities, the initial velocity of the ball is the same as the initial velocity of the plane at the moment of the drop. Okay. Thanks for watching. Stay tuned for more to come.